All right, how is everyone doing today? You sure that's not a little loud? Is that a little loud in back? You sure? All right, it sounds loud to me for some reason. How's everyone doing? Any questions about the project so far? Yes, sir. Yes, so we have those analyze functions. There's like analyze headache, analyze stool, analyze cough. Each one of those essentially does the same thing. And I posted an answer on Piazza about that today. And essentially the thing is that all of those functions do the same thing, which is they can compute an average or they compute a, sorry, there's like an echo, so is that still okay? Okay, so they compute either an average or a standard deviation, right? The thing is we're computing 6 different averages and standard deviations. So instead of writing 6 different functions, each one of which did something specific, I set it up so that there's one function that if you feed it the correct parameters will compute the necessary averages. So if you look on Piazza, I tried to explain that there this morning. Okay, anything else about what's going to be on the final? Any other questions? We weren't really talking about the final. Yes? Yes. Yes, the only time that you're going to see that message that says unable to match subject is if you give one subject file and a different side effect file. For this assignment, all the subject files and side effect files match exactly. So if you ever have any input using the test files that says subject unable to be found, then something has gone wrong because it is not, the files are set up so there should be a one-to-one match of subject IDs between them. Okay? I won't guarantee they're in the correct order though. So you actually have to look and make sure that things are going in the right spot. English has synonyms. Yes, some people call it a mutator, some people call it an accessor. Yes, sure. Any other questions? Do you care? Okay. So, other questions? All right, so somebody pointed out to me in my office hours yesterday that the assignment is due on Monday, right? And what office hours are available to you on Sunday? How much office hours are available? Like not very much, right? So you know what happens on Sundays? Is you all email me. And I'm a nice guy sometimes. And I try to answer your emails. But this Sunday, I'm not going to be able to answer your emails because I have to do stuff this weekend. So for one time only, I'm going to delay the due date of this assignment through Wednesday so that you will be able to get help on Monday and Tuesday and will not be emailing me all weekend. Okay? I'm sorry I have to do this. I know you all are disappointed. So now here's the deal. Stop. Project 5 will still be due at the same time and will still be assigned early next week. Okay? So you will not have extra time on Project 5. Yep. It's like the last 2 days. It's like Wednesday the 7th of December or something like that. So you will still have time. It's just that some of your time will be eaten up when you're on Thanksgiving break and not doing any work anyway. Yep. All right, can everybody be quiet, please, so I can hear the question? Yes, of course we have class next Wednesday. Why do you keep asking me that? Other people ask me that too. It is an official class day on the register. We will have class that day. For me not to have class that day would be cheating you all out of the education that you have paid for. I'm not going to cheat you on that. Yeah. Yes. Yeah. So, other questions? So, and I'm working on the autograder. The other reason I'm giving you an extension is I'm a little behind on that, so because I'm kind of burned out and I've been working nights and weekends for like the last month and I needed a weekend off. So, okay. Other questions about the project? Does the feeling that you have an extension mean that you don't have to think about it now? You can put it off till like next Tuesday or something? How many of y'all think that? How many of y'all have messed up and haven't started early enough on at least one project? Did I warn you the first day of class? Yes, I did. Okay, so now, any other questions before we get started? No other questions. So today, Computer Science 1, otherwise known as Now We Get to the Good Stuff. Okay? Everything you've been learning up to now has been relatively basic, right? It's kind of like if you were learning a language and you're asking, how do I go to the bathroom? Where is the beach? Things like that, okay? You don't yet have enough in your mastery to do the cool stuff, the really cool stuff. Why do you look so afraid? Anyway, today's the day we get to the good stuff, okay? For the first time. And what I'd like to do is talk to you about some of this good stuff. So here's what we're going to do. We're going to talk about delivering pizzas. Here we have a pizza box, and here we have a bunch of houses. So how do we figure out where the pizzas go? Pardon? Yeah. I could ask for the address, but that seems so impersonal, doesn't it? How about if we know that we have to take the pizza to Sally? So somebody says, please take the pizza to Sally. You know where Sally's house is. It's the very first one. So what do? Because you know Sally. You've known Sally your whole life. Don't you remember? I'm sorry she wouldn't go to the prom with you, but it all worked out for the best. So no, so we know Sally. Sorry. Would you like a piece of candy just for that? So anyway. So, because we know where Sally's house is, just because we know, right? That's Sally's house. It says so right there. Okay, so what do? You can just take her the pizza, right? You take Sally the pizza because you know where Sally's house is because Sally, it says so right there, right? Everybody with me on this? Really straightforward, right? Like, have your parents ever asked you to do an errand? Hey, take this to your dad, take this to your brother, right? You know where they are, and so you just go do it. So we can deliver the pizza to Sally by name with no problem. Right? Now, some people were pointing out that Sally just doesn't have a name at her house, right? It's not just Sally's house. What else does her house have? An address, right? So here's Sally. She lives at 123 Main Street. Okay? Could we also deliver a pizza just to a place by address where we didn't know the person's name? Could we just take it to 129 Main Street? Absolutely. If somebody said, please take this pizza to 129 Main Street, you would just take the pizza to 129 Main Street, and then they would have a pizza, and they would be happy. Okay? So we can deliver the pizza by name, and we can deliver the pizza by address. Okay? Everybody with me on that? Makes sense, right? Okay, there's one other thing that we could do. So say we were going to deliver a pizza, and we weren't sure of the address, but we knew someone who did have the address, right? So here we go. There's Dean's house. He lives right next door to Sally, and we don't know where the pizza goes, but we know that Dean knows where the pizza goes. So we have to deliver the pizza. What do? We ask Dean where the pizza goes, right? And how do we do that? You go to Dean's house, and you say, Dean, where does the pizza go? And Dean says, oh, that pizza, it goes to 131 Main Street. So what do then? You take the pizza down there, and that was 131 Main Street. Whoops, I got a little, no. Getting ahead of myself. Okay, so I forgot to write 131 Main Street down here, but they go in order, 123, 57, 29, 131 Main Street. So we deliver the pizza there. And I'm missing a slide. I forgot to put it in there. And what this is called is we can deliver this pizza by reference, right? And by reference means we refer to Dean, and Dean says, oh yeah, take it right down there. Everybody good with that too? This one probably doesn't happen as much as the others, right? It's not often you call Domino's or Lido's. Where do you all get pizza from? Domino's, and say, hey, go ask the person that you know, and they'll tell you where to bring the pizza, right? You just do that. But is this possible? And what's nice about this? Anything? Well, you actually waste a little time because you have to go ask Dean things. But the nice thing about this is that at different times, Dean might tell you to deliver pizzas at different places, right? So anyway, okay, my analogy is breaking down, so let's just move on. Okay, so what does this have to do with computer science? Anybody want to say it has nothing to do? That would be really funny one day if I just came up with some random example that had nothing to do and led you all through it, and then just went on and did something else. But you all might remember this diagram. Do you remember this? What is this a picture of? A memory, right? Because when we had memory, we talked about RAM, and we talked about RAM having a whole bunch of these little boxes we could store things in. How many were there? Like on order of magnitude? Tens, hundreds, thousands, millions, billions, trillions, quadrillions. What? Billions, yes. Tens of billions, hundreds of billions of these. Okay, we have a lot of these boxes to store things in, and that's the power of the computer. And each one of them has an address, okay? And here I just started numbering them from 0 up to 9. And if we were going to go on, we'd number every one of these with their own address. What would the next address be if I had room for one more box on here? What? 0xa, right? This is hexadecimal because it's 0 is x, and 10 is actually a. So the next one would be 0xa. So this is hexadecimal address. So we have a lot of these boxes. When we have a variable, and we say we have the variable count, we are actually assigning a name to one of these boxes, right? Aren't we? So the box count also has an address, which is what? 1, right? 0x1. It has address number 1. So when we say count equals 1, what happens? What does this assignment statement do? It goes to the count box and it sticks a 1 in there. Now, this is sort of similar to one of our analogies that we saw, isn't it? Which one is it similar to? It's kind of similar to this, isn't it? We used a name, and we said, hey, take the pizza to Sally. We did it by name, and the pizza ended up there, right? In the same way we do that, we can assign things by name, right? And we're assigning things by name here in our... So here's my question to you. If we can assign things by name, could we also maybe do it by address? How do you know? It does, of course, and I've already said that I wasn't leading you down a straight path today, so maybe someday. Okay, so here's what we're going to do. We're going to start talking about this stuff. Hang on 1 second, I forgot to make myself a file here. Okay, so here is a simple program, right? This is our standard #include iostream, namespace main. Okay, so let's declare a variable. What variable would you like to declare? Okay, int count, and what is this going to be initially? 0. Okay, and so let's output what count is. How does that look so far? Is this so basic it's boring now? Even though it was baffling a few weeks ago, perhaps? So let's compile this. And that compiled cleanly, so let's run it. What's this going to output? Count is 0. All right, everybody good with that? All right, what I want to show you now is the address operator. And what the address operator does, it is the ampersand, okay? What the address operator does is put in front of a variable, provides the address where that is stored. So here's what we're going to do. We're going to see out angle count is at address, ampersand count. Doesn't matter if the space is there or not. Okay. All right, everybody good with this? So let's see what this outputs. Anybody want to guess what this is going to output, roughly? What we might see here? A what? A hexadecimal. And what is a hexadecimal? What does it represent? Yep. And it is the place, but it is also, is it like a string or a floating point value? Yeah. It's a binary, but it indicates something. It is just an integer. It is a very large integer. Okay? So when we see this hexadecimal thing, don't get surprised that it's hexadecimal. The only reason it's really hexadecimal is because it's a much more compact format than a lot of digits. Okay? So you can just think of this as an integer. So let's compile this again. That seems to work. Let's outrun it and see. And you'll see here that address is at this very large number. 7FFFBD 4EA98. Okay? So our computer, and this computer has billions of addresses, right? Billions and billions of one. And it just happened to choose this particular address to store count. Okay. Everybody with me so far? Yeah. Yep. And in fact, if we run this a bunch of times, we get different addresses every single time. See, now it's B20A instead of BD4. Because every time the program runs, it's likely to choose a different place. This is one of the problems we have when we don't assign things, since it's grabbing some place in memory. Remember, if you don't initialize something, what do you have in that box? You just don't know, right? And because it's not putting things in the same place every time. Yep, see, right here. 0, 0, 0. It's just using, every time we run the program, it's using a different box in memory. Just whatever happens to be convenient at the time. Okay? Does that make sense? Was there a second question? Was that the same one? All right. So everybody sees this? Everybody kind of aware of what's going on, right? We have all these boxes. One of them is named count. In fact, it's the only one we're using in our program. We stuck a 0 inside there. But we also looked, and using the ampersand said, oh, out of all the billions of boxes we have on the computer, count is stored in this one. Got it? So what's cool about this ampersand thing is it tells you where things are. Okay. Now, what can we do with this address, do you think? Yep. We could store the address someplace, right? Like the address itself, what is the address? It is just a great big integer, right? That's all it is a great big integer. Can the computer store great big integers? Absolutely. So later we'll look at how to store this, okay? But one of the things, remember we were talking about delivering pizzas by name, and then we delivered pizza by, and we talked about assigning variables by name, and so it now follows that we're going to talk about assigning variables by. So if we have this address, how can we use it? How can we use it? So let's try something. I have no idea what's going to happen here. So let's do this. Let's say if we try to say the address of count equals 12. So we're now working with the address, and we're trying to assign that equal to 12. Let's see what happens when we compile that. I actually don't know. Yep. So what the compiler is telling us is that the address of count was actually this box, like 0x7FFFF. We can't just randomly change the address. We can't just say, hey, make the address of count 12. Can't do that. It won't just randomly move things around in memory for us, because trying to do this would literally be saying, hey, the address of count before was 7FFF5AC2DX or whatever, and now making it 12, and the compiler goes, look, I'm not going to move that box someplace for you. Everybody understand that? Yes? Who's with me? Who's against me? I had him. Yes, anyway. That's what happens when you incur my wrath. Okay. So we have a problem. We can't do that. So we can't just assign things directly to an address. But here is what we can do. We can use another operator, which is a star. It is shift 8. Means go to the address. Go to the address. So if we put a star in front of here and we say star ampersand count equals 12, what this means is get the address of count. In fact, I'm going to put some parentheses around here just to make it a little bit cleaner. Okay? Get the address of count. And the star operator means go to that address. Literally go to that box in memory. And when you get there, make that box equal to 12. Okay? So this is also what's known, the star operator is the dereference operator. Because this thing, this address, is a reference. We call that a reference to some place. And star means go to that place or dereference that. Okay. So what do you think, if we see out count after this, what do you think it will be? If all goes well, then count will be 12. All right, should we compile it and see if it works? Compiled cleanly. All right, count is 0. Count is at address 7FFFB4 48FA888. And look, count is now 12. Let's go through this again because it's important. And I don't want to leave anybody behind, okay? What is count? It's the name of a variable. And what kind of thing does this variable hold? An integer. Everybody with me on that? What is and, the ampersand of count? It is the address, and out of all the boxes in memory we have to store things, it is the address where count is stored. Okay? Everybody got that? What does star do? It says star means if there's a star and an address, and we just talked, is ampersand count an address? It is. It means go to that address, and when you reach that box, put in 12. Yeah? You can. You can absolutely say count equals 12. They are identical. Now your question is, why do we bother to do this? And the answer is because almost everything that I have called magic over the entire course of the semester has to do with this. Okay? And so almost everything that I have said magic over the course of the semester has to do with this ability to work on things by address instead of by name. And we're about to take a 1-minute break. So you want a preview of coming attractions? We're going to get rid of names. All right, you have 1-minute break. No, because this isn't object oriented. These are just like fundamental memory operations in C. So not quite. If it helps to think of that way, I wouldn't say otherwise, but it's not quite exactly the same as that. All right, welcome back. How are you all doing? Who is sad that they might lose all their favorite variable names? So here's a problem, right? Here's a problem. Say that we are dealing with some data, and we're going to be loading a whole bunch of things out of the file. How many things are in the file? How many things are in the file? You don't know. So if you had to create variables with names for everything in that file, how many variables would you create? You don't know. And you can't possibly create enough names for everything that would be in that file, right? So we need something else. And what we're going to see is that we're going to start having data that instead of having name has addresses. So that, for example, as you're reading things out of the file and putting them in memory, each thing will have an address, but it won't have a name. Now this sounds confusing, but it actually turns out to be incredibly powerful. Incredibly powerful. It is the secret behind vectors. This is what vectors are doing. What we're talking about touches on a lot of stuff, okay? And when you get to data structures is all about how to store data in a sane way, and I'll try and give you a preview of that later in the semester, okay? But let's get back to this. What does the ampersand mean? The address. That is the address operator. What does the ampersand mean? One more time, this side's too quiet. What does the ampersand mean? What does the star operator mean? It is dereference. It says go to that address. And when you get there, do something. So having and count means get the address of count. Star means go to that address. And when you get there, put 12 in it. Now, it was pointed out that we could also access count just by name, right? So remember when we were delivering pizzas to Sally? We could say, hey, take a pizza to Sally, and the pizza would get to Sally. Or we could say, Sally's address is 123 Main Street. That would be the ampersand part. And then we would say, go there, which would be the star, and deliver the pizza there. Everybody with me? Seriously? Okay. Because it's important. All right. So let's do some other stuff now. I mean, we talked earlier about being able to store addresses in a variable, right? Because isn't an address just a big number? And can't we put big numbers in a variable? Absolutely can. So what we want to do now is look at this. So I'm going to do it the wrong way first, and we'll just try it and see what happens. So we can do something a long integer. In fact, we could probably make this unsigned because there are no addresses below 0. And we could see out and just see how this works out. Okay, so everybody sees what we're doing here, right? We know that addresses, like here is the address of count. We know that address is just a big number. It's an integer number. It's not going to be less than 0. So we'll say it's an unsigned long address of count and stick it in there, and then we'll output it, and we'll see what happens. We might get a compiler warning. Yep. So here's the thing. Does it make sense that an unsigned long would work? Is that the right type to hold a great big integer number that would be in memory? Yes, it is. Okay. But what are programmers? They are lazy. And how many programmers do you think want to type unsigned long over and over and over again? None. Okay. So we have a special notation for this. When you try to store the address of something into a variable, there is a special notation for this. Now, here is the bad news. The bad news is that this special notation is very confusing. Okay? It's very confusing, this special notation. And I kind of wish it was something else, but it's not. So here is how you do how you do this. When you want to store the address of something, put a comment here. When you want to store the address of something, here's what you do. You figure out what type that box has inside of it, which is in this case an int, right? What does count hold inside of it? What does count hold inside of it? An int. Count can hold ints. And so what we're going to say is that this is going to be the address of count, and we're going to use this special notation to say that it is the address. Okay? So when you say ampersand operator, that means get the address of something. When you say int star, this means it is the address of something that can hold an integer. It is the address of something that can hold an integer. So when you see anything star like that, that means it is an address of something. So address of count right now is not holding a value for count. It is holding literally the address of something that can have an int and that happens to be pointing at count. You remember in our initial example in the little PowerPoint we had Dean. Remember we went and asked Dean where to take the pizza? That's what we're doing now. Okay? This thing, address of count, will store the address of count, and we know it's an address because it has the star. Remember when I said it was sad that the notation was confusing? Have we seen the star for anything else? It is also the dereferencing operator. Okay? So you'll see the star in two different places. You'll see the star in two different places. You will see it when something is a variable that can hold an address. And in that case, it's the type, the thing that can hold, followed by a star. This means this is going to be the address, because there's a star, of something that can hold an integer. And we have count, which can hold an integer, and we put the ampersand and we get the address of it. Yep. No. This is just, this int happens to be what this variable count can hold. So if we had the address of something that was a double, we would say double star. Yep. Yes. This thing will work for anything. You can have these for anything. You can have the address of any variable, and you can store the address of any variable. You just put the type, like Boolean string, person, subject, vector, whatever, star, and that means the address of that thing. And it will store. This, all right, here's two ways. Let me think about, let's put it this way. So let's pretend the int isn't there for the time being. Okay? When you see a variable declaration that says star and then the variable name, that means it's going to be holding an address. The address is always going to be the same regardless of what is in the box, right? Because we have a whole bunch of boxes. They're all numbered along. And so the star means you have the address of one of those boxes. The int part here means, by the way, that box is currently holding an integer. It has nothing to do with the address. This thing means star. Yep. It is, you ready for this? It is a pointer. It is a pointer. Okay, so if you have something that looks like this, type star and then some variable name, this is called a pointer. And a pointer is actually the address of something on the system. So in this case, we'll say, right here, we have address of count equals ampersand of count. We have int star. We have a pointer here stored in address of count that points at count. Everybody sort of with me? And This type right here, which is the same as int down here, doesn't refer to the address. It refers to what is stored at that address. So if you remember our analogy, I closed Keynote, didn't I? Let me just bring that back up really fast. So if we go back to this analogy, right? Remember we had Dean, and Dean knew where the pizza went? Dean is actually a pointer to where the pizza goes. And you can think of Dean as storing the address that things have to go to. And it is sort of its own type, okay? It is sort of its own type. It is an address that's in there. We call it a pointer. In fact, it's just another bunch of bits, but it's not quite like an int or a long or anything we've seen before, because now instead of holding a value that we're interested in working with, it holds the address of something that we're interested in getting to. Okay. All right, I know I had you all right up to the point where we started talking about pointers and that second star popped up and everybody went, oh. And everybody's sitting there pretending that they're happy and that they understand what's going on because they're assuming that they're the only one who doesn't. So, how many of you all think you understand this? How many of you pretty sure you don't? Want me to go over it one more time? Thank you. Love honesty. So, yep. So this is weird, okay? It's weird. So let's just go through it again. Let's just step through main and see what happens, okay? Where do we start? And what's the first thing we do? We declare a variable named count, and what do we put in there? And we output count is, and what do we get? 0. Now we're saying, okay, now we have ampersand count. What is ampersand count? The address. It is the number of the box that count is stored in. And so when we output this, what do we get? Some big hex number, right? That is literally an address. And you all were good with this, right? Okay. Now what we saw is that we have this star, which is the dereference operator. Okay? A star is a dereference operator. And right next to that, we had this thing, ampersand count. What was that? Ampersand count, we just saw up here, is the address of count. Dereference means go to that address. Okay? So we looked at this thing, ampersand count, and we said, oh, that's 7FF whatever. We dereferenced it, and when we got there, we put 12 in that box. That box also happens to have the name count, right? We can get to it two ways. We can get to it either through its name or through its address. And after we output this, we saw count is now count. Then we said to ourselves, if we're working with addresses and they're just big numbers, can't we store those big numbers in one of those boxes as well? And we said to ourselves, yes, we could. And we tried to do it in a way that sort of made sense with an unsigned long, but then we found out that that doesn't work. And instead, we have to use this notation. And the notation is a type and a star. That thing declares this star declares as an address. And the int says, if you were to go to that address, what would you find on the other side? And in this case, it's an int because that was where count was. Now, the baffling thing is that we saw the star right here. How is this star different than this star right there? Like, what is the difference between the two if you're reading it? Yep.
So the first star is actually dereferencing the value.
No, I'm just physically, like, how can you tell these two stars apart? Not what do they do? Yeah, so in this one, what's in front of this star? There's no type in front of it, is there? If there is no type in front of it, that means it is the dereference operator. Okay? That means it's the dereference operator. If there is a type in front of it, what does it mean? It means it's a variable that holds an address. But it is not an integer. That means this is the variable that holds an address, and if you go to that address, you will find at that address an integer. So when you start doing this stuff, it's very baffling. And you know how I know it's baffling? because it was baffling for me, like the first time I saw it. It was baffling for me for like a month, maybe even more than a month. I mean, it's kind of weird, right? Because you're using the same thing over and over again. But I'm just trying to get you to understand this. The ampersand gives you the address of something. The star without a type in front of it means go to that address. And if the star with a type in front of it means you are declaring a variable that is something that holds an address. So if you ever see the star and you're not sure what it is, what do you look for in front of it? The type, okay? And that will tell you the two apart. And I'm going to tell you one more thing. After today, you're not going to have to worry about the ampersand anymore because that's going to go away. Because the ampersand is how we get the address from a name. But what I'm telling you is we're going to do away with names. So in a little while, there will only be stars. Yep. Uh-huh. So the question was, if you dereferenced just some particular random number, would you find out what was in the address at that, what in the box in that address? And the answer is yes. That is exactly how it works. You want to just put in some numbers? Now I'm warning you, what's going to happen is that the operating system of the computer is very protective of its memory. And so what's going to happen is if we just type random things in, we will get errors. But this will be a useful experiment because, well, let's finish. We haven't even run this one yet, have we? So, all right, so let's compile this one because I changed it from a long int, and we will run it now and make sure it still works. Okay, so count is 0. Count as an address 7FF563 FDA78. Count is now 12. And then after we have stored count in a box and we say output the address, notice that the address is identical. We have stored that address safely in a box. Okay? Everybody with me? I know you're really excited about galloping off and just doing bad things to memory, which is great. I love that instinct. It's fantastic. So, and Java, how many of y'all ever worked in Java? Does Java have pointers like this? No, Java is greedy. Java does not give you access to the memory. And it makes me mad at Java sometimes that it doesn't do that. So, okay. All right, so let's see. So we have this thing stored as an address. How do we, if we print out the address, we just get the address. How do we get what's at that address? Okay, so here's what happens. We say the address of count when stored is address of count. The value stored at, the dereference of address of count is, this address of count is what? What is that? It's an address. How do we know it's an address? Because we put a star when we declared it, which means it's an address. If it has a star when it's declared, that means you can use the star to dereference it and find out what's there. When we run this, what will happen is we will see again that the value stored at star address of count is also 12. So we are accessing the same box multiple ways. First, we are accessing it by name, right? Then we are showing that it has an address. Then we access it by dereferencing that address. Then we store that address in a different box, and then we dereference that address from the box. So we're getting to the same box in lots of different ways. Everybody good so far? What is the difference between the star that doesn't have a type in front of it and the star that does have a type in front of it? Star that doesn't have a type is, and the star that has a type in front of it is, it's a declaration of a variable that holds an address. Okay? So when you're looking at code and you're trying to figure out what to do, if you're trying to declare a variable, you want the type in star. If you're trying to dereference it, you just want the star. And the ampersand eventually we're not going to care about. Really, you almost never use the ampersand in real life. Oh, except in one place. Where? Reference parameters. Oh, so can this explain how reference parameters work? It does, doesn't it? Because before, with value parameters, we were copying everything over. But reference parameters, we were just saying, hey, instead of copying everything, use the data that's stored at this address. And that's how reference parameters work. Because instead of making copies, you are working directly on something stored in memory. And when your function returns, those variables are still stored in the same place in memory, and therefore they have changed. The values have changed out of your functions. So there is, like, what's that? That's like 20% of the magic we've been talking about, right? And that's not so hard, is it? You'll get used to it. So, okay. All right, so everybody good on this so far? All right, I've been talking for a 1 minute break. When we come back, we will just randomly attack some memory addresses and see what happens. So, just for fun. All right, welcome back. Sorry more of you didn't stand up when you had the chance. It's good for you. So we had a request, and the request was just to randomly attack some memory addresses and see what was there. So let's see what happens if we just start couting. And so this is totally for fun. You don't need to know this. It's just, it's kind of fun to do stuff like this. All right, so here we go. Totally for fun. Cout, what do you want to do? You want to dereference what address? Give me an address. All right, we got to make sure you have the right 1, 2, 3, 4. All right, 1, 2, 3. Okay. So I'm not sure. Let's see. Okay, 420. I don't know why you chose that number. Okay, can't take a type in. Okay, so here's let's do. Let's do this. Let's say we're going to have a pointer to something that's going to be called attack equals 420. Because it doesn't like that, so let's just say dereference attack. So here we are. We're saying, oh, sorry about that. So we're saying this thing is going to be an address of an integer. We're going to store it in attack, and we're going to give it initially a value of 420. Okay, and then we'll see out. Let's see if that works. Okay. No, it's honestly that you just never really do this. Like you never really just like type in addresses this way. Sure, you want to try that and see, but not sure that's going to do much either. So the problem is that the compiler is not going to just randomly let us put addresses in there, like as literals. I haven't done this in a long time. I don't remember how to do it off the top of my head, so. We might have to maybe cast it. Yeah. It will eventually. So anyway, all right. Well, we won't do that right now. So, all right. Sorry about that. So if I can figure out by next class, I'll show you how. Okay. I haven't done that in a long time. All right. So that was totally for fun. apropos of nothing. Okay, so everybody good so far? Any questions on this? I know, does it feel like I'm saying the same thing over and over and over and over and over and over again? To me too, but I don't want to just like leave people confused because this stuff is confusing. I totally understand. All right, everybody good? So let's talk about one other thing. So far, all the addresses we've seen come from this thing count, which is a variable. And it has a name, right? Does it do us any particular good to figure out what count's address is and access it that way? No, right? Because we could just use the name, right? We could just use the name. So, if we're going to make this thing be useful, what we need to do is create variables that don't have names. Okay? Because the power of these pointers comes from being able to have addresses of lots of things, but not have to access them with their names, because then we can just have, like, imagine a big vector of addresses, each of which pointed off to something, right? We would be able to have a lot of stuff, and then we only need the name of the vector. Does that make sense? We're not going to do it that way, but that's kind of what you know. So if you have a vector of addresses, you can imagine having a whole bunch of addresses, and each one points off to something else. And then the only name we need is for the name of the vector, and then inside the vector we have a bunch of stuff. Does that sort of make sense? So we need to be able to make things without. So here's what we're going to do. We're going to do this. We're going to say int star address of int without a name. What does this mean? What does the star mean? And how do you know it's a variable for an address rather than the dereference pointer? What does this type indicate? When you go to that address, what you can find there. Okay. And what we need to do is we need a way of creating a new thing of that type. Yep. So here's what we have. We have this function called new. New. When you use the new function and you give it a type, it will create a box that has an address that stores this type, int. And what is the name of that box? Nope. It doesn't have one. Okay, so I'll show you in just a sec what's going on here, okay? So we say int star address of int without a name means this thing, this address of int without a name, is an address because the star is there, and the thing it points to is an integer, okay? So this variable is going to hold the address of a box that contains an integer. But instead of making it point at count like we did before, we're going to say new integer. So the compiler will say, okay, here is a brand new box that can hold an integer for you, and by the way, here's its address. How do you get to that box if you need to get to that box? Yep, you have to. So here's what we're going to do. Now what we're going to say is we're going to see out angle. I don't know what should we output here. Let's do this. We will say star address of int without a name equals, what do you want to set it equal to? All right. Okay. And if we want to see what's in there, we say star address of int without a name. We'll see that out and see what's in there, okay? So let's make sure that works. I didn't make any huge mistakes this time. 420. Okay. And check this out. Here's what we can do. We can say the value of the int stored at So now what we're saying is the value of an int stored at address of int without a name. This is a variable that holds an address. And so this will actually output the address. And then we'll say is, and then star address of int without the name will follow along to what's in that box and show us what's in the box. Yeah. Yep. But they do very different things. Wildly different things. Yep. Uh-huh. Exactly. So this is a great example, right? Here we have a star. We have int star. What is this? You see a star that has a type in front of it? It's a declaration. And is a declaration of a box that holds an address. Okay? And the thing we're putting in this address is what comes out of this new function we've called, which is called new. And new just creates things of a particular type and returns their address. So new says, oh, you need an integer? Here's a box that can store an integer, and it's stored at this particular address. Okay? This star, since there is no type in front of it, means dereference an address. And which address? The address that is stored in the box address of an int without a name. In fact, if I wanted to do something like this, I'm never mind, sorry. So star address of int without a name. So it means go to that address and store the value 420 there. Now what we're going to do is we're going to print out two things. We're going to print out this address. Is there a star in front of that? So what is it going to be? What is going to output there? A big hexadecimal value. And this one has the same thing, but it has a star in front of it. So what is that going to output? It's going to go to that address and see. So let's see if that works or not. There we go. The value of the int stored at 0x7FTC2460050E0 is 420. Okay. What is the name of the box that holds that value 420? What is the name of the box that holds the... What's its name? It does not have one. It doesn't have a name. Before, when we were talking about count, count was the name of a box. We could go to the box by name. But now, can we go to that box by name? Because it doesn't have one. It only has an address. So let's go back and look at this really fast, right? So remember this? Right? Originally we were delivering pizzas. We delivered them by name. We just said that pizza goes to Sally. That's like saying you're taking count equals 4. Just put that pizza over there in 4. That's a horrible analogy, but I misspoke. Does that make sense, right? We're just doing things by name. Then we said we could do things just by address, right? This is literally what we did when we said, hey, ampersand count, go there. Of course, this doesn't have the same address, but you can go things by address. You don't need the name. The other thing you can do is this. We have a box that has some knowledge, right? It has an address in it. It's like Dean in this analogy. Dean knows where the pizza goes. Address of int without a name knows where that int is. But to actually get there, you have to dereference it and follow it all the way over there. Okay. Who's with me? Who's sad? This is power right here. Remember like day one I told you this class should be called Power Through Computer Science? Pointers are power. They are. Because you can build anything. You can build amazing things with pointers. Yep. This function? We're going to get to that. But here's the answer. The answer is that we have to have at least one name. And the reason we have to have at least one name is we have to as programmers, be able to access the place where that address is stored. Okay? So we have to have the name of at least one pointer because that pointer is going to tell us where our data is stored. Now what you don't see yet is how we are going to start using the addresses to hook lots of things together and build these big, intricate, beautiful, amazing structures of data that you only need one name to get to, and then you start following addresses all around until you get where you want to go. Okay? And we will get to that next class, or maybe a little bit this class. All right, yep. Down here? I just didn't put the parentheses in there, but I could. Here I put star ampersand count because I was trying to get the address of this named variable. Ampersand is how you get the address of the named variable, and then go to there. But down here, this thing, address of an int without a name, was already something that holds an address. It gets confusing, right? What is count? What is count? What kind of variable? What does it hold? It holds an integer, right? It doesn't hold an address. So if we want to use the dereference on count, we have to get its address first. We're not really going to do things this way. Like, the only reason I show you this is to help you understand the operators. And I know it's a little bit confusing at first. Trust me, ampersand's going to go away in a little bit, and all we're going to have is stars. But I want you to understand that these are actually boxes that we're putting in. Yep. Exactly. Once we get rid of names, we will have no need for ampersand. And in fact, since we have names, we don't even really need the ampersand. I'm just trying to demonstrate to you what's going on. Okay? The new is a special function that, when you give it a type, goes out into memory and finds an empty box and says, ah, this box will do for you, and then says, okay, here's the address of the box that you can use. If we used old? No, you cannot use old. No, there's no, new is special. New means give me a new one, right? It's a special function that does stuff. So you can't just type anything instead of new and expect it to work. Yes? Oh, good question. Does it clean the box? I don't know. What do you think? How about this? How about we just comment this line out for a sec? See this line right here? What does this line do? It says, find the address of int without a name, get it out of the box with that name, go there, and when you get to that box, put 420 in it. But I commented it out. So now, what is going to be in that box when we get there? Who said we don't know? We're getting a lot of zeros, but you can see it's just luck so far. Like if we ran this long enough, yeah, we're getting a lot of zeros. I mean, it just depends what's going on. Sometimes you'll get zeros, but you can't count on it. Let's see. At. Nope. I know for a fact it does not. And if we wait long enough, then eventually one of those things won't be zero, I promise you. And the reason, you know how I know? Because I have forgotten to assign my pointers, and sometimes you get a random pointer that has an unknown value that just points someplace randomly in memory, and then you're in trouble because you're now manipulating pointers. I'm getting really annoyed that this is zero. Because I promise you it's not always zero. I swear to you. Oh, maybe that's the problem then, is that, oh yeah, it is the same address. Oh, wait, one went by. Come back. It was just me typing something. But I can promise you it is not always zero. I can swear. And I have not spent 2 days debugging things from forgetting to initialize a pointer. But I have spent a good portion of my life trying to fix bugs caused by the fact that people didn't initialize pointers. In fact, yeah, anyway, you'll see. All right. Everybody good so far? I'm really annoyed that that didn't come out non-zero at least once. So, but that's just the way it is. Okay. All right. Get this back again. All right. So now we're seeing things. Okay. Everybody good with that? Yep.
Wait, so if the box isn't clear, what if there isn't an int in there, and then you said this box is an int?
Yeah. Everything is, all right, so the question for those of you who are watching online is that, so say that it doesn't turn out to be 0. That you say, hey, I need a box, and it's going to, oh, you know what, new might always initialize it. That might be the problem. Okay, but say you end up with you get a box, and there's something already in there, right? And the problem is it used to be a double, or a string, or something like that. It's still a bunch of bits. Right? And what the compiler will do is goes, oh, there's a bunch of bits in there. They must be an integer because that's what you told me it would be. So I'm going to pretend that this bunch of bits is an integer, regardless of what it was before. And so what value do you get? Some bizarre random value. Yeah. And that's why you kind of get random stuff in there. All right? All right. So now what? The question is, how do we use these things, right? Like, let's try and draw a picture. That might be the best way to do this. This isn't like the best drawing program I have here, but it'll work. Okay. So here's what we have right now. We have something we declare. We do say it's some int star address of thing, right? And what we get, oh man, I'm in trouble here. Okay. What we get is a box. What we get is a box here. 2 hours, man. Yeah, sorry. I wish I had a drawing program on this computer, but I don't have a good one. All right, we get a box. This is absurd. Why am I doing it this way? You know, the reason I'm doing this way is I would normally do it on the chalkboard, but then it wouldn't be on the recording. Do you want me to do it this way so it's on the recording, or do you want me to do it on the chalkboard? All right, chalkboard, recording. Okay. All right. I see what's going on here. All right. So we have this box, which is an int star address of thing, and this inside here will have some 0x7ff, right? Whatever. All right. Right? And what this really is a pointer to another box. Ooh, I think I can make this faster. To another box that actually has some integer value in it. What's in this box? What value do you want in here? 47 or something. And so here, like this, to get to this box, you would literally say star address of thing, right? Like that. So this int address of thing, and actually I should put in here equals new int. So we get some address that we're able to put something in, and then if we dereference it and say this is equal to 47, then we have this box that's 47. Okay? It's pretty sophisticated, advanced classroom technology right there, right? So we're drawing this stuff. So, all right, everybody with me so far? You see the difference of these, right? Int star means that we are declaring a variable that holds the address of something that points to an integer. Equals new int means there's a box somewhere. Then star address of thing means dereference it, and when you get there, put 47 in it. So what happens is it goes, oh, it looks at this address, dereference it to this box, put 47 there. Okay. This is not useful. And it's not useful because we still have a name, right? This thing doesn't have a name, but this one up there does. We haven't actually saved ourselves any difficulty, have we? But how about this? How about instead of int, we declare a little class? and we'll call it the link class. And the link class will have some public stuff, which we can worry about later, and it will have some private stuff. And it's going to have two things in its private thing. All right, it's going to have an int, some value, but it's also going to have an int star for the next value. And here's what we're going to do. Instead of having a pointer that points at something, we are going to have special boxes. We're going to do something like this. We're going to say int, we're going to say link star. This is a pointer to a link, and this is the head of the list. Okay? And equals a new link. All right? Sort of getting ahead of myself here. But here's what we're going to end up with. Let me just copy this box again. Here's what we're going to end up with. In fact, let me take that out. We are going to end up with a series of boxes that look like this. Oh, man. Someday I will figure out how to get like a drawing program that works well so I can draw pictures. We're going to end up with something like this. We will have a box that has a value in it. I have no idea how I'm going to do this again. And then it also has a link to the next thing in the chain. Okay. Oh, man. Sorry about this. Should have just done it on the chalkboard. When I was a kid, this is all the graphics we had. Okay. Right, like this. And so you can imagine I can't even draw an arrow here because there, imagine that's an arrow. So here's what we're going to have, right? We will have one thing that is a variable that points at this first link in the chain. The link will have a value. That just took way too much time. The link will have a value, but it'll also have an address of the next thing. The next thing will have a value. It will also have an address of the next thing. So we will have one name, and that name is actually like a pointer to something. And that will go to the first link, which will take us to the second link, which will take us to the third link, which will take us to the fourth link, which will take us to the 10 millionth link, right? Because we are linking all these things together by address. But we only have one name, and the name is so that we can get to the first one. Otherwise, what we'll have to do is follow the addresses all the way through. I told you it was getting good, didn't I? So, have a good weekend. I'm going to update the Project 4 code when I have a chance. And next time when we come back, we will look at this a little bit more. I'll draw some prettier pictures. So.